In number 12, we are going to use a proportion to solve for a missing part. And that proportion is made up of setting two ratios equal to one another. Those ratios come from side lengths of triangles. And we obviously have one large triangle here, but because of this line here, this altitude, it splits it off into another small triangle there, and then kind of a medium triangle over here on this side. And so which of those three triangles should we use? Because we're going to compare two of them, and it really depends on what sides within those triangles we know. So for example, if I look at this large triangle, there's two sides that I know of. I know the short side and I know the hypotenuse. Okay? Even though the hypotenuse is a variable, that's what I'm looking for, so I can use it. The same thing can be said about this short or small triangle over here. I have the hypotenuse of 60 and a short side of 36. So that one looks like I'm going to use it too. The one that I'm not going to use is the medium triangle. The reason is because I really only have one side that I know something about. This long leg is going to be x minus 36 based on the information below, but I don't know anything about the short side and I don't know anything about the hypotenuse. So I'm not going to use that medium side. Okay, so that's the first thing I need to do is determine, like in this case, small triangle and the large triangle, they're ones that I'm going to compare. The second thing that you need to do then is just indicate where you want to put information about those triangles. I just write it on the side here. So let's put all the information that we know about the small triangle as the numerators, and the large triangle we'll put as the denominators. It wouldn't matter, we could have switched that around as long as you keep it consistent. And then what is it that you know about those triangles? Two sides. We know the hypotenuse in each one, so I'll put that one here, and we know the short leg in each one. And again, I could have switched those around, but as long as I keep it consistent, my ratios will be fine. Once you've got that template all drawn out and you know where you're going to put stuff, now you find what that stuff is, what that information is, and you plug it into the proportion. So that looking at this small triangle, I want to know what that hypotenuse is. Well, there it is of 60. And if I look at that small triangle and find the short leg, that would be this one down here of 36. Now I can fill out my denominators. Those denominators are going to be based off of the large triangle here. Well, the large triangle hypotenuse is this entire length there, which we're calling x. That's the missing value that we're trying to find. And the large triangle short side is going to be 60, so that goes down here. I've got the template that I used, and now the values plugged into those templates, so now it's just a matter of cross multiplying and dividing. So I would look at this and say, well, 60 times 60 is going to be 3,600, and we're going to set that equal to the other cross product, which is 36 times x, and now I can get x by itself by dividing by 36, and if I do it to one side, I've got to do it to the other side. Okay, so those cancel. I'm left with just x. It's supposed to be an equal sign. And 3,600 divided by 36 is 100. Okay, so that tells me that this entire distance is 100. And I was able to do that because of the proportions that I'm setting up of ratios from different similar triangles.